All right, welcome everybody. Good morning, good afternoon, good evening, depending on where you have joined from. Today we have Hugo Kornelis with us. If you have been working with SQL Server and specifically your focus has been around query tuning and more precisely execution plans, I am sure you have come across Hugo. If you haven't come across Hugo's blog or you haven't heard this name, then you haven't done much work with execution plans. Sorry to get you offended, but probably that's the reality. My name is Amit Bansal, and again, pretty excited to host so many of you and excited to host Hugo, someone whom I have been known for so many years. I think it has been the first time I met Hugo was at SQL Bits, and since then we have been talking a lot of SQL Server performance tuning stuff. So truly excited, and even more, I'm excited that Hugo is actually presenting a full day. It's virtual, so I'll say hours, full 8 hours training class at Data Platform Virtual Summit 2021. So let's move forward. And yes, today's webinar topic is execution plans. Where do I start? We will hand over to Hugo in about 2 to 3 minutes. And I will take this time to just quickly introduce you to Data Platform Virtual Summit 2021 training classes. This is a pretty massive event around Azure data analytics and AI, and I'm assuming that by now you already know what DPS is. So it's a virtual conference. It has been happening in India for many years. Last 2 years, due to obvious reasons, the pandemic, we have gone virtual, and it has opened a lot of doors for us where we are able to get some world-class experts to you at the convenience of your home or office, and that's how we also have Hugo here with us. So we have lined up about 15 training classes. The conference is one part. The training class, which is a combination of pre-cons and post-cons, is another part. And these are 8 hours training classes divided into 2 days. 4 hours each day. And while we have 15 classes lined up for you covering almost everything under Azure data stack, so we talk about machine learning, AI, SQL Server, both DBA, Dev, Power BI, data deployment on Azure Data Factory, PowerShell, I mean, you name it and we have it. And the best thing about DPS this year is if you book any training class for yourself, you get free access to the summit, including all the recordings. So the summit comes along with the training class. And because you are today's delegate, you can even save $20 with this special code, which is only known to you, save 20. That's there at the bottom right there. All the links are there in the chat window, so you may just save it for your reference. I'll take a moment and focus on Hugo's class, which is execution plans in depth. And I will strongly recommend, I mean, you go ask anybody in SQL community and you would get a pointer to this kind of content from Hugo. So if you're very serious about SQL Server, specifically going deep inside execution plans in your endeavors with performance tuning, query tuning, this is a class that you do not want to miss. Now, this is the first time we are hosting Hugo with a training class at DPS, so we're truly excited. After the end of this webinar, Hugo may take a few minutes to talk about what exactly is he covering in this training class. One quick thing, if you attend this training class, you will of course get live attendance, and one of the good things we have done with DPS last year and we are doing this year as well, we record the training class and you get 12-month streaming access of the class recording. So just trying to offer you more value with this. DPS for us, content has always been the king. So here is another announcement. More than 100 breakout sessions have been announced, which is like about 50 to 60 sessions from the community. MVPs worldwide are speaking at DPS, and we have about another 40 sessions from Microsoft engineering teams, product team members. So 100 sessions are live. Just go to dataplatformvirtualsummit.com and explore the sessions tab or the classes tab to see what content is being covered. And we used this last year as well, and of course this year, freshly baked sessions as we call it. We just try to focus that we bring you more fresh and curated content rather than repetitive sessions. That has been the effort. So you may see a lot of new titles, a lot of new abstracts, and a lot of new content that may be more relevant for you this year. So that's it. I'm not going to bore you more. So just go ahead, talk to your managers, get sponsored, come over DPS. And remember, you don't need to really buy a ticket for DPS, the summit. You just need to book a class for yourself. The summit comes along. Well, with this, over to the rock star, Hugo Cornelis. Hugo, over to you. Thank you.
Thank you, Amit. What an amazing introduction. Thank you very much. I cannot fill those shoes you just left for me. I'll try my best. Um, so yeah, I'm going to talk about execution plans, and where most people know me for rather deep, in-depth content, I am actually going to just cover the basics. This is a getting started session. So just to set the expectations straight, we're not going to go deep. This is a beginner session. So welcome. Let's click in the right place. My name is Hugo Kornelis, and I make SQLServerFast.com. SQLServerFast.com is a website I started a few years ago because I love execution plans. Big surprise. But Microsoft does not love to document execution plans. The available documentation is extremely limited and often wrong. So I decided I will build a reference where I document everything I can about execution plans. Now, this being a reference, it was not a good teaching and not a good learning experience. And people asked me, you give good training classes, like the 2 times 4 hour training class at DPS that Amit already mentioned. Why don't you make that available as a training material on the internet as well? So I started creating the execution plan video training. Execution plan video training is available at sqlserverfast.com/video. It's in-depth training courses on execution plans where I take the time to talk you through everything. You can pause it, you can speed it up, you can rewatch it. If you purchase it, the purchase is forever. And because I always like it when people come to my sessions, I reward them with a temporary discount code. So if you use the code DPG webinar, you will get a 10% discount if you purchase access to any of my currently available videos. But before you do that, consider whether you want to go to my training class. Because if you go to my training class, you get a better offer. At my training class, I give a 20% discount, and that's not time limited, it's forever. It's for my current videos, it's for all my future videos. So, of course, you will have to wait until my training class, but then you can have that 20% discount where I will give that code. The training class will be given at September 8 and 9 from 2 to 6 universal time code. And as Amit said, you get access to the Data Platform Summit for free thrown in as well. And you just had a $20 discount code. If you are not available to come at September 8 and 9, just check my website. There may be more deliveries of my training day, and those will also give that same 20% discount. Now, enough commercials about me. You want to go to the content. So I have more stuff on my blog. What's most important there is that if you go to the menu choice, other presentations, presentation resources, as shown at the bottom of the screen, then you can find slides, decks, and demo codes for all my presentations, including this one. I do a lot of other stuff. Nobody cares about all the stuff I do, but you do care about my email or my Twitter. I understand that when I'm talking, I'm giving a lot of information. It's going fast. If you have questions, of course, type them in the chat, type them in the Q&A. The moderators will ask them to me. But I understand that maybe your questions come after a few hours of processing all the information. If that happens, mail me, tweet me. I'm always happy to answer questions of people who attended my sessions. So let's get going. What am I going to talk about today? We're going to talk about execution plans. And if you think about execution plans, the first question is, why should we bother with execution plans? Well, you are watching right now, so I hope you already have some idea, but I'm still going to go over that part. And then when I have convinced everyone that yes, you should care, I'm going to show where to find them, and most of all, how to read execution plans. We're going to talk about properties, and at the end of the session, I'm going to do, depending on time, 1 or 2 examples of real queries with their execution plans, where I talk you through how you can relate that execution plan to the query and what it means for performance. Let's start. Why do we even care about execution plans? To understand that, we need to first take a step back to the traditional third generation or procedural languages like Visual Basic, like C Sharp, and many other examples. If I think about those languages, I often compare that to the way I myself see my morning ritual. And the example I'm going to give is pre-COVID. It's slightly changed now. But pre-COVID, my morning ritual was the alarm clock goes, I slap it, put it on snooze. A few minutes later, it goes again. I curse a few times. It's a very important step. I curse a few times, go out of bed, go to the bathroom, take a shower, brush my teeth, dry off, get dressed, take breakfast, get in the car, drive to the office, and start working. That's about my morning ritual. And as you notice, there's a step-by-step description. I have an exact order in which I do stuff. I could make other choices. I could brush my teeth before showering instead of after showering. I could even take my toothbrush under the shower and brush my teeth while showering. Instead of having breakfast and then driving to the office, I could have prepared some bread the night before and eat it while I'm in the traffic jam. Those are choices I make. Now, if you relate this back to a computer, the third generation programming language gives a step-by-step description of what the computer should do, the way I describe my morning routine. Because computers tend to be very good at doing the same thing over and over again, they deal with large collections of data. That's often done with loops, where things repeat. And this is where those choices come in. Sometimes you have multiple ways to do the same task. Those are called algorithms. They should all give the same result. They don't all have the same performance. So if your code runs slow, who are you going to blame? The developer, because the developer chose a bad algorithm and should choose a better algorithm to make the code run faster. Now, this is all third generation. That's not what we deal with when we are working with databases. In databases, we are working with SQL, structured query language, so-called fourth generation language. And coming back to my morning routine example, the SQL version of that is my boss sending me a text the evening before, and the text reads, Hugo, we have an important customer in the office tomorrow, so make sure you're there in 9 and dress appropriately. That's all she sends me. She doesn't care whether I brush my teeth before or after the shower. She just cares that they are brushed when I'm in the office. She doesn't care whether I have a 1 hour long breakfast with my wife before I go to the office, or whether I rush to the office so I can sleep a half an hour later and then quickly eat while in the car. She doesn't care about all that. The only thing my boss cares about is the end result, that I am wearing appropriate clothes and not an offensive t-shirt as I might do if there's no customers in the office, and that I'm there in time. And that's what SQL is as well. So if you work with SQL, you don't tell the computer step by step what to do. You only tell the computer what result you want. And this is done in a set-based way. Set-based is a sort of a mathematical concept, but basically we pretend that the computer is doing it all at once. So we say, give us this result, and in the entire logic of the language, the idea is that it all happens at the same time. Now, that is a nice idea when you look at the language from a logical perspective, but in reality, the computer is still running code on microprocessors. It still only does one thing at a time. Of course, if you have 8 cores, it's doing one thing at a time on each core, but it's never doing everything at the same time. It's still running loops. It's still processing algorithms. So there is a translation from this SQL code that pretends it all happens at once in a set-based logic to the actual step-by-step processing that is done by the CPUs. And this is done by the query optimizer, a very smart piece of software that usually gets it right. So the query optimizer chooses the algorithms, not me, the developer or the DBA. It's the query optimizer that chooses the algorithm to use. Now, this is SQL at a theoretical level. Oh wait, I forgot one thing. Sorry, I was ahead of myself. So the algorithms are chosen by the query optimizer. And that means that when the code runs slow, well, it's still the developer that gets the blame, not the query optimizer. Sure, if my boss curses at me because the code is slow, I can say, hey, it's not my fault. The optimizer made a mistake. You know what my boss will say? I don't care, Hugo, fix it. And she's right, that's my job. But I did not choose the algorithm, and that's where I can run into a problem. So let's take one step back to how T-SQL, how Transact SQL on Microsoft SQL Server works, because that's not true SQL. That's a bit of a hybrid. T-SQL mixes set-based queries, the pure SQL, with procedural code, the third generation concept. So that means if something runs slow, it might be that the procedural code you wrote is slow, or your developer wrote. You can choose a better algorithm, or better, try to rewrite that procedural code as set-based code. This is not true for all database systems, but SQL Server is extremely optimized for set-based code. If you write code that loops over data with cursors or with other stuff, you're probably wasting performance. Let SQL Server handle that. So try to use set-based code unless, and the unless list is very short. But it's also possible if you have a slow code that actually a single query is just too slow. And that's where the problem starts. So I have a single query, and apparently the optimizer picked an algorithm that was not good. The optimizer made a mistake. Now I need to know what algorithm was chosen. Why was it chosen? And what can I do to help the optimizer pick a better algorithm? And to find all that, I need to have insight in what happened. And that is why we need the execution plans, because the execution plans tell us the algorithm that the optimizer picked and include a lot of information to give insight in why the optimizer picked that algorithm. So that is why we should care about execution plans if we care about performance of our queries. Now that we all care, where do we find execution plans? This is a question that can be answered in two ways. It can be answered from the perspective of a production DBA. You have a server, you have hundreds of users, you are using too many resources, your CPUs are constantly 100%, you have lots of users complaining that everything is sluggish, that it feels slow, but there is not a specific pinpointed issue and you need to find what's wrong. This is a very real problem for people in that role, but it's not something I'm going to talk about today because it's not a beginner level question. I have a list of resources on the screen, Plan Cache, Query Store, Extended. Well, you can read them all. Those are all good sources to answer this question. I'm not going to talk about them, but at the end of the session, I'm going to show a list of resources for further reading, which includes a book that covers all these tools that you can use to find problematic execution plans on a busy server. But today I'm going to talk about a different issue. Today I'm going to talk about an issue where you have a specific query and you need to investigate the performance of that query. So perhaps your production DBA just did all those previous things, found out that you made a mess and tells you this query that you deployed yesterday is causing issues, fix it. Or perhaps you are writing a report and you want to make sure the report is fast enough before you even deploy it. Or, well, lots of different examples. The issue is you know which query you are tuning. But you want to know the execution plan so that you can tune it better. How are we going to do that? Let's jump into the demo. And if you download my session materials, either from my website or from the DPG website, you will not only get the slide deck, but also all the demo code I'm using. So all is available to you. Now, let's suppose that this query on your screen right now is running too slow. If this is in production, if this is an actual use case, I would say, hey, you're calling a function literally called delay. Perhaps that's why it's slow. Of course, I'm doing a demo now. This is not realistic. This is simplistic. And I deliberately put the delay in there to slow down the query. So this is just for the example. Yes?
There is a question.
Yes?
So from yes, sir, I request the person to rename. But the question is it true that execution plans interpretation as a skill is less relevant now as Microsoft has fixed a lot of wrong choices of plans?
Microsoft is busy fixing a lot of things. That's correct. First of all, a lot of that is on SQL Server 2019 or on SQL Server vNext, and I do not even know when that will be released. I myself still have SQL Server 2008 boxes with some of my customers and everything in between. Secondary, Microsoft fixes the things that are easy to automatically fix. Execution plans as a skill, I think, becomes more relevant because the things that are not fixed automatically will be harder. The low-hanging fruit, that will be gone because computer algorithms can pick up on the low-hanging fruit. But if that is not enough, if you're still having issues, I think execution plans become more important, not less important. Perhaps there will be less professionals needed, but I think the skill, I think especially people that are good at execution plans, at reading them and at translating them to how to fix this, will be in high demand. Of course, I cannot predict the future, but I'm still investing in my skill in execution plans. I hope that answered the question. So I have a query here. I'm highlighting it. And let's assume I want to know how SQL Server wants to execute this. I have multiple ways to do that. One of them is this button. I'm going to highlight it and then zoom in. So it's this button here. And as you see in the tooltip, the tool calls it Display Estimated Execution Plan. I hate that term. I'll tell you why later. It's not an estimated execution plan. It's an execution plan. So the tool is misleading here. And the standard terminology all across the internet is misleading because this terminology is used. If I click this Display Execution Plan button, SQL Server will show me the execution plan. How do you read this is the next question. We'll get there later. For now, this is the execution plan. This is how SQL Server will execute the query if I ask it to execute the query. But the query itself is not executed. That's why the plan is there immediately. Only time needed is for the optimizer to compile the execution plan, not more. Now, there are also other buttons, like for instance, the button here, which is called Include Actual Execution Plan, but should have been called Include Execution Plan plus Runtime Statistics, because it shows you the same execution plan, but with additional runtime statistics. Now, when I click this button, nothing happens, except that the color changes. It's a toggle, it's an on-off switch. I have now switched it on, which means if I switch it on and then execute the query, SQL Server will not only execute the query, and that takes some time because it's a slow query, but once the execution is done, it will also show me the execution plan. That's the same execution plan we just saw when we clicked the Display Execution Plan button, but with extra information added. And if I click here to get the execution plan, if you remember the picture you saw before, you will see it's the same picture, but there are more numbers on screen. And there's also more numbers elsewhere. I will get to the properties later, but in the properties, you will also find much more information. This is a much richer experience, but in this case, I had to wait 16 seconds before I got the execution plan because you only get it after execution is over. 16 seconds is not a big deal. But if you're working on a report that runs for 2 hours and should be optimized to finish in 10 minutes, then it can be a big deal to have to wait 2 hours before you can even start working. So that's where a third option comes in. Oops, I need to highlight it first. And that's this button called Include Live Query Statistics. This button is also a toggle. So if I switch the execution plan plus runtime statistics off and the live statistics on and execute the query again, you will see that the execution plan appears immediately, but with some additional runtime statistics, and those runtime statistics are constantly being updated as the query is running. Sometimes in that 2-hour running query, this helps you find the issue after 5 minutes already. Sometimes it doesn't, and you still need to wait the 2 hours. At least you didn't lose anything, but you had a chance of winning anything. And what I like to do when I actually have a 2-hour report is include both options. I'm going to execute this query one more time. So now you will see that the live query statistics are there immediately. But at the end, when the query is finished, you will also get a tab with the execution plan plus runtime statistics. And the reason I do both is that the execution plan plus runtime statistics has more information than the live execution plan. So the live execution plan has some runtime statistics. The execution plan has all runtime statistics. So let's recapture this. We have the execution plan, or if you really want to avoid confusion, you could call it execution plan only. And I do not like the term estimated execution plan because it's not an estimate, it's the real execution plan. What happens if you click the button display estimated execution plan? So if you request the execution plan, is that the engine of SQL Server tells the query optimizer, here's a query, I want to execute it. Create a plan for me. The query optimizer says, oh, if you want to execute this query, let me think, here's how you do it. And it returns a plan. And then the engine says, haha, I fooled you. I'm not going to execute the query at all. I just wanted to pick your brain on how you would execute it. But the optimizer doesn't even know that it's preparing a so-called estimated execution plan. The optimizer only knows this is a query and I need to compile a plan for it. So the plan shown is how it will be executed. There are some exceptions that has to do with changes in between the moment the plan is compiled and the moment the plan runs. If there is a long time between that, then the reality may have changed, causing a recompile. That's a new compile. But those are the exceptions. Normally, the execution plan you get when you ask for the execution plan only is the execution plan that will be executed. Then we have the execution plan plus runtime statistics, or for short, execution plan plus, which is also called the actual execution plan. And one of the big reasons I hate these terms, estimated and actual execution plan, is because so many people look at those names and think, oh, so the estimated execution plan is just a quick guess at how SQL Server thinks it will execute the query. But if it actually has to run it, it will do more efforts to come up with the actual execution plan. And that's simply not how it works. If you run a query with the execution plan plus runtime statistics option enabled, then the query optimizer gets the same task of here's your query, come up with a plan. But now the execution plan will actually be executed, and while it's executing, those runtime statistics are added to that plan. So the only difference is that those statistics are there. It's the same plan with more data collected while the query was running. And then, as mentioned, the execution plan with live statistics, also called live execution plan or live query plan. Again, same start. The optimizer is told, here's a query, give me a plan. The optimizer comes up with a plan, but now the plan is shown immediately, and then some, but not all runtime statistics are collected and updated during execution. I'm not going to go through all the details in this chart, and yes, I know that my head is even blocking some of them. You can download the slide deck later. This is just a reference overview that shows all the difference and similarities between the three ways to execute execution plans. And some of these are even out of scope for this session, so I'm not going to talk about all of that. We are going to talk about how do we read those, because we saw some pretty pictures the last 15 minutes. But if you're actually new to execution plans, that doesn't mean nothing to you. And you want to understand what it means. You want to know where to start. So here is an example of a simple execution plan. And this example execution plan, well, basically every execution plan is completely made up of two different elements. One element are the pretty pictures, the icons that have a name and some additional data underneath it. Those are called operators. And those operators, those icons, you can think of them as small programs that are very specialized to do one specific task. So the filter operator you see in the middle of the screen here does one specific task. The table scan operator does a different specific task. It's all small specialized computer programs that do one task. And they are tied together with arrows. The arrows, you can call them data flows. But if you look at the actual underlying source of the execution plan, which is an XML document, and I do not recommend to look at it unless you really want to geek out, because it's really hard to read. But if you look at that XML document, you will find that the arrows are not even there yet. The arrows represent something that is not directly in the plan. We'll return to that later. Let's first talk a bit more about the operators, those small programs that each have their specific task. Each of those programs has three functions, three entry points where it can be called. So each operator can be called with the initialize entry point. And when it's called for that, whoever calls the operator tells you should get ready to do your work, do your preparation. It will always be the first call if an execution plan runs to every operator. It will always start with the initialize call. But sometimes the operator is initialized multiple times. And if the initialize call is done again, it's actually a re-initialize where it just restarts from the top. It just clears everything, prepares to do work, and starts from the top again. Now, why would you do that? Perhaps you just need the same stuff again, and the best way to do it is to execute it again. But sometimes it also has to do with parameters that are used somewhere in the execution plan to affect the behavior of an operator. So if an operator is called to return all data for Bombay, it will return all data for Bombay. But if you then initialize that operator again, but now change the parameter to do everything for Delhi, it will do the same task, but return different data because it's now filtering on Delhi. The most interesting call for operators is the get next. Get next is simply someone telling the operator, I need a row. Give me a row of data. How this row is produced is different for each operator. They all have their own way. That's because they're all different programs with different tasks. But usually, part of that task is getting data from somewhere else because most operators don't get their own data. So most operators, when you ask them for a row, will first ask someone else for a row before they can give you a row. And then there's the close, which I just include for completeness. It's for clearing up. And I have never run into any issue where you needed to care about the close call. It's just good that it's there because it avoids memory leaks. Now, the term operator is used in an overloaded way, which can be confusing if you're not aware of it. So the term operator may be used to denote a generic type of operator, the entire class. The text on the screen is, I think, a literal copy-paste from the execution plan reference. So it's the reference description of the filter operator. In plain English, you could say the filter operator requests rows, runs a test, and only passes the rows where the test is true. This is the generic description. Every operator of the filter type adheres to this description. So the term operator here is about the class. However, the same word operator is also used for instances of that class within a specific execution plan. So a coworker might come to my desk and with their laptop and point at the screen and say, hey, Hugo, I'm looking at this execution plan and there's a filter operator here and there's a filter operator here and there's one here. I understand this one and this one, But that last one, I don't understand that third one. Why is it there? What is it doing? That coworker is now talking about 3 filter operators. He's not talking about the class. He's talking about 3 instances of that class. So the term operator is used for the class and for the instances within the class. And that can be confusing, but it is what it is. And I'm using that term the way everyone uses it, so I'm using it in that same confusing, overloaded way. Usually the context makes it clear. Now, I also want to talk about the errors, the data flows, and they are not actual elements of the plan. They just represent how the operators connect to each other. So the arrows represent which operators call which other operators. And that is something that the optimizer has laid out in the execution plan. So in the execution plan, you can find that every operator will be called by exactly one other operator, and it will also return rows to that operator, because if an operator is called by another operator, that will be the getNext call, and the answer will be a row, because that's what getNext does. The calling operator is usually called the parent, and the called operator is usually called the child. Now, where every operator has exactly one parent, the reverse is not true. An operator may have 0, 1, or more child operators. There's no limit on that, although some operator classes have specific limits. Some operators always have one child, other operator classes always have more than one child, etc. If you put all this together, you get what mathematicians call a tree. That's a term from graph theory. You don't need to know graph theory to understand execution plans, but it is interesting to know that the term node, which is a term from graph theory, has trickled its way into execution plans, and you will sometimes hear the term node when talking about an instance of an operator within an execution plan. There are some things in execution plans that are very frequently misunderstood. And I really want to call them out because they are so common mistakes. I want all of you to know to avoid those. First of all, the cost percentages. I'll just show in a demo what I mean. Let's assume, and again, this is completely silly. This is not something you should do in real code. This is a terrible practice. It's something I abused for this demo. So don't use this as an example of how to tune a query. It's not. Don't use this as an example of how to code. It's not. But let's assume that this here is a slow query, and my boss asked me make it faster. And I did some rewrites in the query. I changed the logic a bit, making sure that the results are still the same, but the method is different. And I think this is a faster query. Now, what I have seen some people do is select both queries and then ask for the execution plan only. So they click here, they ask the execution plan only, and we're going to ignore this assign plan here. That assignment has to do with this assignment. You can always ignore those. They're just there because that's how SQL Server works. So we have 2 real execution plans, one for the slow query that I was given to tune, and one for my attempt to make it faster. And now when I zoom in, you will see that the first query has a cost of 99% of the batch, and my faster query is only 1%. I made the query 100 times faster. I'm a tuning god. I'm awesome. I deserve a raise, right? Everyone agree? I'm fantastic. And then along comes a pesky person who says, and again, I don't like the terminology, but people will say it. Yeah, but this is an estimated plan only. Look here, it says estimated. So perhaps the estimate is wrong. Okay. Let's include the actual execution plan. Actual should be right, correct? So let's look at the actual data. I've toggled on the include actual plan. I'm going to execute 2 queries. Look at the execution plan. See, I am a tuning god. Still 99% for the slow query, 1% for my better version. Go away, your screen. So this looks awesome, right? Well, before I go to my boss and actually ask for the raise, I might want to do something else. I might want to check in a different way. So now I'm going to enable statistics, Iowa statistics time. And I'm going to run those same two queries once more. And I'm going to look at the outputs. Now the slow query took 52 milliseconds. It's a bit to the bottom of the screen and did 689 logical reads. That was 99%. And then I came along and I made it 100 times faster. And now it took, what? 307 milliseconds. And it did 94,000 logical reads. That's not right. That's not really 100 times faster, right? Something went wrong. Now, and even when this option is enabled, even when SQL Server knows that's 94,000 logical reads versus 689, 300 milliseconds versus 52 milliseconds, even then, SQL Server still tells me, no, 99%, 1%, the second one is better. It's not. So where do these numbers come from? Well, if I hover my mouse here, and I will zoom in again, you will see a number called the estimated subtree cost of 0.584. If I do that same hovering trick over the select in the second query, you will see that that number is 0.065. And here's the deal. It's an estimated subtree cost. Estimated. I can't stress and highlight it enough. It's an estimate. It is in the execution plan when you ask an execution plan only. It's still there if you ask an execution plan plus runtime statistics, and there's no additional runtime cost data added. So the only thing that the Management Studio has to compute this 1% and 99% is the estimate. And if you realize that
there is a question, Hugo, here.
Yeah, I will finish this sentence and then I'll take it.
Yeah.
If you realize that a lot of real life performance issues are caused because there is a mistake in the estimations, then if you are basing your query on numbers computed off that estimate, you're just going to repeat the errors that the optimizer made because you're using the same incorrect data. What was the question?
Yeah. Where to find the actual execution plan with the runtime stats? Any DMV gives that for a query which already executed and they're in the cache.
I think that's since 2017 or 2019. I don't know by head which version it was introduced. It was a recent introduction. There is a DMV that stores the last execution plan plus runtime statistics. So that every time the query executed, it's replaced because, of course, the runtime statistics are different every time. And it stores the last one. I don't know by head which it is, but in the resources on the last slide, that one is also covered. It's a great question, by the way. So now, knowing that those 99% and 1% that we have here is so misleading, how about this 3% here? Because that's also what I see people do. They look at a slow query, just a slow query. Let's do only this one. And they say, hey, here is 93%. This is where the time is spent. But this number is also based on the estimated operator cost as a percentage of the estimated cost of the entire plan. So again, if the estimates are wrong, then this number means exactly nothing. Zero. It's just misleading. If all your estimates are correct, then this number means something, but maybe still not what you think it means. So those cost percentages, yeah, they look deceptively easy, but very often they're just deceptive. They are based, like I said, on the estimated cost, which is based on the estimated number of rows, which is often wrong because it's an estimate. But there's also other reasons why it can be off, because even if the estimated row counts are correct, your hardware is not the same as the hardware someone else uses. What is running fast on your computer may be slow on someone else's computer. Maybe I have more RAM and a slower disk in my computer. Maybe you have a less RAM, but a faster disk. That changes what operators are good for you and what operators are good for me, but those numbers will be the same. The second very popular misunderstanding is how to read execution plans. And when I do live presentations with a room in front of me, I always do a show of hands here. How do you read an execution plan? Left to right to left, or something else? And I bet that everyone listening now, of the people listening now, I bet that at least 95% will think, oh, I would answer right to left. It's always the case. 95% say right to left, 3 or 4% say left to right, and the rest says something else. The rest is correct, because you do not always read an execution plan right to left. You also do not always read it left to right. You have to understand what those directions mean in execution plans. So let's imagine that this execution plan is actually running. And remember, operators are called with a get next. That's when they start doing action. So the select operator you see right here is not a real operator. The select operator pretends to be an operator, but it's actually a representation of the client program that requests rows. So it starts with the select, the client program, asking the filter operator, hey, give me a row. A filter will be like, sure, I love to give you a row, but I have no rows myself. So, hey, table scan, give me a row. And table scan is one of those rare operators that can actually get data from somewhere else, in this case from a table. So it reads the table, gets a row, and says, hey, filter, here is your row, enjoy. And filter, doing what it's good at, looks at the row, looks at some specific conditions, says, no. This row is no good. I don't want it. Get out of my life. I don't want this row. Table scan, give me another row. The table scan will be like, sure, your call. Here's your next row. The filter will once more look at the row and say, oh, this is a beautiful row. I love this row. I'm going to pass this row on to the select. And then this process repeats when select asks for the next row. Now, the red arrows, and in case anyone is colorblind, those are the arrows right to left marked with the get next below them. The left to right arrows, the right are in red. Those represent the flow of control. Those represent in which order operators start running. And this is important because if, for instance, the filter operator sees a reason to not call table scan at all, then it won't start running. And if you start reading at the right-hand side of the execution plan, you will not even be aware of that. You will waste time on looking at that table scan that didn't even do anything. The right to left arrows, blue for those who see colors, represent the flow of data. And the reason so many people read execution plans right to left is because as long as you're aware that flow of control is left to right and flow of data is right to left, as long as you're aware that something, sometimes it's conditional whether something executes at all, following the data is often a good way to figure out how an execution plan works. So yes, right to left can be a good strategy after you confirm that the branch executes at all. Left to right can be a good strategy unless it's so complex that you need to follow the data. And if you have a real big execution plan, sometimes you just start in the middle. Sometimes you do look at those cost percentages, knowing that there's an estimate, but at least it gives you an indication that there might be an issue there if you see a high cost percentage. You should be aware that it's based on an estimate. You should be aware that you might be misled, but at least you can use it as a starting point if you have a freaking huge execution plan with 200 operators in there, because you need to start somewhere. Now, there's one other element in execution plans that I haven't shown before, and those are the properties. And the properties in the execution plan are like the not tip of the iceberg. Oh, yes.
Yep.
Question.
Question from Pooja again. how to find the sort warnings or memory warnings, etc. from XML plan. Graphical plan shows fine, but in case if we need to do plan cache analysis to find out all the plans with sort warnings, how do we do that anyway?
That's way beyond the scope of this session. So the question is, how do you find in the plan cache or execution plans with plan warnings? That's way beyond the scope of the session. Resources give you some hints. You might also want to Google for blogs. I think people like Grant Fritchie might have blogged about this. What you do is you query the plan cache where the execution plans are stored as XML. And then you either use the XML as just a varchar with a like pattern, or you do XML shredding on the data, and you get very complex query expressions. And like I said, it's way beyond the scope, but that's one way you can find all plans with warnings in the plan cache. However, the plan cache stores the execution plan only. It does not store execution plan plus runtime statistics. And a lot of the warnings you're interested in are in the runtime statistics and not in the execution plan. Some warnings are in the execution plan only, but most are in execution plan plus. So that means on newer versions, you can use that DMV I mentioned before that stores the last execution plan plus runtime statistics. But if you're really interested in those warnings, I would usually just use extended events where you can trace for specific hash warnings or sort warnings. And because I'm way beyond my scope, I'm going to leave it at that. So,
Arthur has a question.
yes.
So does this select pseudo operator actually also receives rows as they flow row by row?
Yes. Because the select represents the client. The client says get next into the first operator of the execution plan, and eventually a row returns, and then the client will ask for the next row. Management Studio does that. If you write .NET code, then I don't know the exact .NET methods. Fill table will of course do it over and over and over again because it fills the entire table. But if you use, I don't know the exact method, but there's a .NET method that requests single row. That's by the layer in between, just translated into a get next call and returns one row, and that's it. And then you call it again, usually. So if you look at an execution plan, if you look at just a graphical execution plan, you're looking at the tip of the iceberg, and most of the good stuff is below the surface in the properties. You do want to look at the properties, but they are not as visible as the rest of the execution plan. So let's look at the demo to see how that works. So I have two queries here. And if I select both queries and ask for the execution plan only, you see 2 times. And if you just look at the graphical version, you should see the same execution plan twice. But the execution engine only gets the execution plan. The execution engine never receives the query. It only receives the execution plan. So if both queries have the same execution plan, you would expect that the results are the same. But of course, they are not. It's different queries. The first query returns more columns. The first query also returns more rows. The second query has a filter on rows and has less columns. So they don't do the same thing, even though the execution plans look exactly the same and pretend they do the same thing. So how does the execution engine know that it should not return all columns for the second query? Well, that is in the properties. And if I hover my mouse over the clustered index scan operator, you will see a window pop up with a lot of extra information. And those are the properties. And one is, for instance, the output list property. And here you see a list of 5 column names. And those are exactly the 5 column names that are returned for when we run this query. So this is how the execution engine knows to return only those 5 columns, because the optimizer put this property in the execution plan. You don't see it if you just watch the execution plan on your screen. You do see it as soon as you hover your mouse to access the properties. If I do the same hovering trick on the clustered index scan above, you will see that the output list is a lot longer. In fact, it's so long that it doesn't fit here. You see an ellipsis here to tell you, hey, I didn't fit everything on the screen. I had a space issue, so this is just a part of it. So where do you find the rest? Well, you right-click the operator, you select Properties. And in my case, the only thing that happens when I do that is that this window here is highlighted, the Properties window. And I'm going to drag it out now, put it in the middle of the screen. But if I close this window, then right-click and Properties opens it again. If I keep it open, then I never have to right-click again because I can just change focus. When I click on the select, you will see the data in the Properties window change. So leaving this window always open, and that's why I normally have it docked, but I move it out now because my face would be in the way, gives me easy access to the properties. And in this properties window, I can now scroll down to that same output list, and here you will then see the full list of all the data in there. And it's still hard to read with all this plus clicking and so. There's also another way, and that's just to click on the ellipsis button, and then it will open in a separate text window. And I'm going to dock this again because I like it when that window is there. So that's how you access the properties. Like I showed in the demo, you can hover over an icon, but you don't see all the properties. I didn't call that out during the demo, but when you look at this property list, you get a selection of the properties. You don't get all properties. And Microsoft shows what properties are there, and I do not always agree with their choices. I think some of the properties they put in there are a waste of screen space. I also think that some of the properties they did not put in there should really have been in there. But luckily, we can always use the full properties list by right-click to open the window or leave the window open and just change focus. I skipped over a slide. I'm going to go back now because I also didn't show this in the demo, but you can also hover your mouse over an arrow. Now, arrows do not exist in the execution plan. So the properties you see when you hover over an arrow are not the properties of that data flow. They are properties of the operator to the right of that arrow. And it's just a subset that focuses on the amount of data. So it pretends to be properties for the data flow, but in reality, it's properties of the operator pertaining to the data produced by that operator. The top left operator, I already mentioned it before, it's not a real operator, but it still has a lot of properties. And those are properties that relate to the plan as a whole. So I'm going to jump back into the demo one more time and put this on the screen again. If I hover over the select here, you will see a pop-up that has almost nothing. This is really a very limited pop-up that does not do the pseudo operator justice. If I click the select, you will see that the amount of data here is impressive. I'll just have to use zoom in a different way. So what we have here is, for instance, a cardinality estimation model version. Which version of the cardinality estimator was used? Information about the memory grant. Not so interesting in this case because there was no memory grant, but if you have memory issues, it can be very important information here. What query time statistics? If you normally run your queries with set query IO on, you get that same information here. You don't need to use query statistics IO on anymore. Weight flags, weight stats. What weight stats were done? So we have 17 milliseconds weight type memory allocation external. And the most important weight stat here was async network IO. So this query was slow because the network wasn't fast enough. So all this information and much more is available in the properties of the top left operator. And that's a huge amount of information that you really should use. Most of the time, most people will tell you, start there. I often start there. I sometimes forget, and then sometimes I chastise myself because I wasted time that I should not have wasted, because you should start with the top left operator. For all other operators, those are properties that apply to that operator. Some of them change the behavior of that operator, like the output list I showed before. Some of them are reflections of runtime statistics, so they can tell you what happened when the query executed, and more. Now, I cannot go over all the properties. There are thousands of properties. Most of them have a fairly self-explanatory name. But if you are ever in doubt, you can always go to sql7fast.com/EPR, execution plan reference. It's not yet complete, but I'm building more and more, and you will find documentation of all properties there eventually. So I'm almost out of time, but I do want to go through one example to show you how you can apply this knowledge to an actual query and execution plan. And it will be pretty simple because, of course, we're just starting, but it should give you an idea how to start. Now, I have a query here that does, well, what it does is not really important. We're only interested in how it does it. So I look at the query, and let's just scroll a little bit so that the query is just visible and we have more screen real estate for the execution plan. And let's look at the execution plan. Now, I have the execution plan plus runtime statistics because this query is fast enough and I want all the information. And in this case, I have already prepared some work, so I know it's safe in this case to start at the right-hand side and just follow the data. So, but if you realize how it works, it actually select, call stop, call stream aggregate, call sort, calls nested loops, all those operators just start their task by calling someone else. They all, as the first step, say, I need data first. So that's why this first trickling of execution from select top stream aggregate is very fast, and the first real action starts at the index seek. And what will this index seek do? Well, we'll have to look at the properties. And this is where I should move around myself a bit because otherwise you won't see it. So the index seek has a lot of properties, and one of them says you need to use an index to find product ID 710. Index seek is an operator that finds data really fast based on an index. In this case, the index called IX, sales order detail product ID. And it uses that operator, that index, to quickly find data for product ID 710. When it finds those rows, it will return two columns, sales order ID and sales order detail ID. Now, if you look at the execution plan, you will see that sales order ID is indeed used. Sales order detail ID is never used in this query. So it's a bit weird that SQL Server returns sales order detail ID even though it's not used anywhere. If you just look at this operator, this is confusing. So let's not just look at this operator, let's see what happens next. So this index seek finds those rows, and as soon as it finds one, it returns it to the nested loops operator. And the nested loops operator does something called an outer references. And outer references means that data received from the top input is pushed into the bottom input. And here we see this sales order detail ID together with sales order ID. So those two columns that were read for product ID 710 are now pushed into this key lookup operator. And this key lookup operator is like an index seek. It also has a seek predicates to find specific data. This is not finding for product ID 710. This is finding data for sales order ID plus sales order detail ID equal to the sales order ID and sales order detail ID that were read by this index seek, passed to this nested loops, and then because of this outer references, passed here. So that's why we needed the sales order detail ID, because this key lookup looks in the primary key index, and the primary key index is on sales order ID plus sales order detail ID, and that's why both these columns were needed so that the order quantity, let's clean all the notes, so that the output list could return the order quantity. And we need the order quantity because the order quantity is actually used in the query. Now, a similar pattern is then used to find data from sales order header, also with an outer references. I'm going to skip that a bit for time reasons. Then all the data is passed to a sort, and the sort will collect all the data, will wait until all the data is there, and then order that data by customer ID. And it's another case where I get curious because, yeah, I have an order by in my query, but the order by is by total quantity. I don't order by customer ID. I group by customer ID. So why is this sort needed? Well, and that's the benefit of writing the execution plan reference. I know all this by head. You would have to look it up. But I know that the stream aggregate is an operator that does aggregation. Well, aggregation is stuff like group by and compute account and the sum. So it makes sense that we have something for aggregation, but the stream aggregate is one of the operators that does aggregation. The stream aggregate only works correctly if data is sorted by whatever you're grouping on. So the reason the sort is here is because that is needed for the stream aggregate to work correctly. And the stream aggregate will then return the customer ID, which makes sense because we have that in the query, and two columns with a weird name, EXPR and the number. You often see that EXPR is shorthand for expression, and SQL Server uses 4-digit numbers to get those names unique within the execution plan. But what is in those numbers? Well, that is not visible here in the pop-up. So for that, I actually have to go to the full properties list, to the defined values, and I'm going to just put it on the screen here, and I will enlarge it a bit. So here you will see that EXPR 1010 is count star, and EXPR 1003 is a sum of the order quantity. And I highlight the interesting stuff because I know there's a lot of confusing stuff on there, because in execution plans, it's always 4-part naming and brackets and parentheses, and Microsoft makes it as hard as possible to read this. So you have to dig in and really find the stuff. But if you find hard enough, you will eventually find it. Now, after this aggregation, what is left is one row per customer ID with the count and the sum. So basically already this information, but it's not yet sorted by total quantity, and we also don't have the top 10 yet, and that's what the top n sort does. And if you look at the properties of the top n sort, and I will scroll down here, you will see that here is the number 10, which matches the top 10 we have in our query. So this is how you can read and work your way through an execution plan. The second query is almost the same. I changed one thing, only the product ID. That very small change has a dramatic effect on the execution plan. This execution plan looks totally different. Instead of a sort plus a stream aggregate, there's a hash match. Instead of seeks and lookups and nested loops, there's now scans and a hash match. All of that is because SQL Server estimates that there will be way more data for product ID 711 than for 710. For the very low number of rows predicted for product ID 710, the optimizer makes different choices than for the very high number predicted for product ID 711. So the optimizer adapts the plan based on the estimates. That's also why very often when your query is running slow, the root cause is a bad estimate. This execution plan, if this execution plan would be used for the amount of data that 710 actually returns, or if the first execution plan would be used for 711, you would probably have bad performance. So I don't have the time to go over the details here because I'm already a bit over, but I did want to show that those estimates have a huge influence on the execution plans. Now, I promised you a lot of resources. There is a great book written by Grant Fritchie. I was the technical editor for that book. It's a great book to bring you from a getting started level to at least an intermediate level in working with execution plans. Best news, it's free. You can download it, and there is a long URL. I hate long URLs, so I made a tiny URL for it. tinyurl.com/redgateexecplans. I hope it still works. If it doesn't work, send me an email and I'll find a new link for you. You can download it completely for free. If you prefer to have a printed paper copy, you can go to amazon.com, but that's not free. Again, time for a gratuitous plug. My training class, Execution Plans in Depth, 8 hours of in-depth training where I go much deeper than today. Obviously, I talk about almost every operator, tell you how they work, what they do, what properties you need to look at. It will be delivered 8 and 9 September at the Data Platform Virtual Summit 2021. I'm always submitting it to other conferences, so it will probably be run again in the future, but I don't know when. If you want to be sure that you catch it, come to Data Platform Virtual Summit. You can, of course, watch my training videos. If you purchase access before 15 August, you can use the 10% discount code DPG webinar. Or if you plan to go to my training class, wait until that's over, use the 20% discount code I'm going to give you there. If you have a Pluralsight subscription, there's a lot of good stuff there as well. And if you just want the reference data, go to sqlserverfast.com/EPR. That's a lot of links. I hope you can benefit from some of them. Are there any last questions at this time?
Yeah, Hugo. There is one question from Anurag. Do we need to know about all operators in order to understand the execution plans?
You do probably not need to know about all operators. There's at least 80 operators, and some of them I have never encountered in the wild. You do need to know about the most common operators, which will obviously come as you start working with execution plans. Typically, you start working with execution plans with a basic knowledge of some operators. I already covered a few today. If you run into an operator you've never seen before, go to the internet, find some information. Hopefully, you will find it on the execution plan reference. There are other sites as well. And then you know one more operator. So you gradually build your knowledge over time. You do not need to study all operators before you start working with execution plans. If you want to learn Italian, you don't need to know the entire dictionary by head before you read your first Italian text. More questions?
Perfect, Hugo. As more questions come in, and we'll wait for a minute or so. But thank you so very much. I know we have an in-depth training class at TPS. Hugo already mentioned this training class. Just note down this discount code, SAVE20, which gives you $20 off on this training class. Not to mention, this is one of our fastest selling training class at DPS 2021. So go ahead, book your seat. We do not have too many seats left for some of these training classes out there. Remember, you get the recordings free for the class recordings, and you also get a full live attendance plus recording pass for DPS 2020. 100 sessions, 2021. 100 plus sessions are already announced. Hugo, would you like to just quickly talk about this training class, maybe 30 seconds, as to what exactly are you covering in 8 hours?
30 seconds is very short, but let me try. My idea is not to give you a bag of tricks for common patterns that you can solve. My idea is to teach you how to read execution plans. So if you compare it to other training classes, you will have less immediate benefit. I will be honest about that. I have been to other training classes where you just walked away with a bag of tricks you could use. You will have less immediate benefit, but more long-term benefit, because instead of teaching you to recognize 20 patterns, I teach you to read execution plans and eventually understand all patterns. But it does take some more effort after you finish my my class. I give you the basics, I teach you everything, but you need to apply it. And I trust that you are all smart enough to apply it once I teach you those basics. And I always get good feedback, so I guess most people like it.
Perfect. And friends, go to the link, dataplatformvirtualsummit.com, jump over to the classes section. Right on the top menu, you will see the first menu, classes. Explore Hugo Kornelis class on execution plans. He has detailed out the abstract, the modules, etc. So you'll get the finer details of what's going to be covered in the class. Well, we have more webinars coming up, so just jump over to the same registration link that you have been coming to. And well, that's pretty much it. You'll get a email from us when the recordings are up. Do download SQL Server Geeks magazine. Also, jump over to sqlservergeeks.com. Yeah, that's like a sister concern of Data Platform Geeks. So jump over to sqlservergeeks.com and you can download the SQL Server magazine, also a new community initiative from us. Well, Hugo, any final words before we wind up today's webinar?
Just thanks for having me. It was my pleasure to present to you and to your awesome audience. And I hope to see some of you, well, not literally, but I hope that some of you will see me in September.
Absolutely, Hugo. Always a pleasure to host you, and thank you so much for giving your time today to the audience. Thank you, friends. Wherever you are, keep safe and have a good day ahead and the rest of the week. See you soon, hopefully, and some of you may come to Hugo's class. So see you in September at Data Platform Virtual Summit 2021. Thank you very much. Goodbye.